Okay. Our next speaker and last speaker for the evening is Richard Schneeman. We know him as Sneems. He works at Heroku, maintains Code Trash, and organizes Keep Ruby Weird. And he is going to talk today about performance optimizing your code. So, over to you.
Good to go? Do we have audio on? All right. I'm going to go ahead and get off the stage now. Thank you all very much for coming. T is okay, no. So, I hope you're ready for a cinematic experience. I need a lot more audio than that. There we go.
I'd say that before slow-mo, I became the typical, institutionalized, educated Western man. In other words, I was driving a BMW to work, I was working long hours, I was paying my taxes and doing everything by the standards of society and so on, just like everybody else in the workforce. And frankly, I intended just to work myself on into oblivion and get old and die. And that was pretty much the scenario. But now, I experience myself like the tip of a great iceberg of consciousness.
We were just talking. Hello? Test. Okay. We were just talking about working out. Surprisingly, that actually got my heart rate up. So I do want to give special thanks to slowmothemovie.com. I'm going to be playing clips from it today. That was one of them. I didn't make this movie, and it's free. It's online. Whew. Okay. So I would like to first off introduce you to Dr. John Kitchen. John Kitchen is a neurologist, a very, very successful doctor. He has a huge house, many fancy cars, and unfortunately for Dr. John Kitchen, he's deeply unhappy. He one day woke up and decided that he doesn't need to live a life of excess, and he can live a more focused life and live life by his rules. And so he transformed himself into Dr. John Kitchen, the skater. He quit his job, he sold his house, he skates around a boardwalk at an insanely slow pace, which is why people call him slow-mo, and that's exactly what he wanted to do. So what is your life goal? Just right now, I mean, just think to yourself, do you want to grow up, pick a career, buy a sports car, retire? Well, if you want to do those things, chances are the faster the better. Early retirement, yeah, you know, bought a sports car at like age 13. Woo. So slow-mo teaches us that moving quickly towards the wrong goal is worse than moving slowly towards the right goal. So I'd also like to introduce you to Schneems, the narrator. Schneems is pronounced like schnapps. It just helps you. The narrator said, explaining his own introduction. Schneems also works for a company called Heroku. It's a small startup based out of San Francisco. You might have also heard of it. Recently, we introduced a feature that allows auto-scaling of your web dynos, so that's like a thing, I guess. I also maintain Sprockets, which powers the Rails asset pipeline, and today I'm going to be talking about some performance improvements along with Sprockets. Though I will say, those are all really just my hobbies. My full-time job is actually resisting the Trump administration. I don't know if you've been following the news, but it's just awful. Every day, it's just awful. So I do consider myself a very chill person. Recently, I've been trying to do some more workouts. I've recently been going and doing yoga, and I like to mix my yoga with resistance, with my practice of resistance. And so I do that by chanting Om. Okay, so I gave a talk at in India about it was back in 2013, and this is backed by popular demand. In the rest of my talk, we're not going to be using any nils, only non. And I do apologize for the non jokes. Some of them do fall a little bit flat. Okay, so this talk is about speed.
New life, like be another person, reinvent myself. I don't have to be a doctor to the last minute and then keel off into the oblivion that way. And I remember that old guy saying, do what you want to, so I started coning down on it. And I found out all I really wanted to do was the basic things and skate. And every day I would come out and just skate as long as I could. And sometimes I would skate like even through the night. I just loved to skate. I loved the feeling, and the more attention I could put to it, the more enjoyable it got. But it was the only really spiritual part of my life. I'd be out there thinking about God and subjectivity, and every night I just went back to it like some sort of religious thing. I think what I'm doing, with all due modesty, is a type of flying.
All right, so the fastest way to get where you're going largely depends on where you are going. To get there faster, we can slow down. When we apply this to code, we ask ourselves, okay, well, why would we want slower code? We want to go fast. The largest reason is to measure it. I mentioned that we're going to be looking at sprockets. This is a profiling script I wrote in just a rake task. We are going to be using stackprof, and with stackprof, you just wrap the thing that you want to measure. In this case, we're invoking a rake assets precompile task. And then afterwards, you use the stackprof command over the dump file that it generated. When you do this, it'll give you an output that looks a little bit like this. I'm going to break it down for you. On this side, we have just the class and method name. And so stackprof works by, as your program is running, it just periodically says, hey, Ruby, what are you doing? What are you doing now? What are you doing now? What are you doing now? And it records that. It doesn't impact the execution time of your program terribly much. And so in this case, we can see the class and method name of where your code was executing, as well as the total number of samples that were sampled while that class and method name were executing. The percentage of those, and then the total number that was at the top of the stack and the percentage of that. So what that means, when you're looking at this, that these top two lines, you can see if you look at the percentage and add them together, that those top two account for about 26% of our total execution time in compiling assets. So 26% of all of asset compile time is spent in just those two methods. The top one is set include. And now we have to ask the question, okay, well given this information, what is calling set include so much? To do that, we can run another command, the same stackprof command, and pass it -- method along with set include. It's also okay if sorry in the back if this is a little on the small side, but I will be publishing my slides. You can take a look and you'll get better access to the commands then. So when you call this -- method, we can see exactly what is calling set include. So here we have valid processor metadata value, which leads to ask the next question of what is calling this method so much. We can see the callers, we can see the callees, and then when we rerun this with -- method, sprockets processor utils, valid processor metadata value, again we're digging deeper. we'll see the method body that we're spending so much time in. So this is the method body of our valid processor metadata utils. To blow it up, it looks a little bit something like this. And you can here you can see we have two constants, and we're calling include on each of them. And basically what this method is doing, it's saying that a valid metadata type might be a string or a number, integer in Ruby 2.4, and valid metadata compound types would be like an array or a hash, things that you can loop through. And the idea is you pass in a hash, and it will tell you if all of the types inside of that hash are valid. And so it loops through, and it's recursive. One of the things that you may or may not know is if you look at the implementation for set include, it looks a little bit like this. It's actually just calling set. All sets are powered by hash under the hood. So one of the ways that we can skip the set is just to directly use a hash. Yeah, excellent question. Thank you, Van Wilder. So Ruby has optimized instruction calls for optimized hash instructions for hash calls. We can use the Ruby VM sequence compile and pass it code. Here we're passing in, we're creating a hash, and then we are calling it with the brackets. And you can see down here we have opt_aref. Now it's fine if you don't know what opt_aref is, but we can just compare and contrast a set. If we use that with set, and you put a diff between the two, we don't get that opt_aref. What you do get is this opt_send without block. And if you don't know that, you can use one of your chatbots to ask. Personally, I like Siri. Hey Siri, how can you optimize Ruby hash calls?
Let me think.
Okay, great. So Siri pulled up this file, which coincidentally pulled up the next slide in my slide deck. This is insns.def. Maybe Mats can tell us what that stands for. Instructions, there we go. Okay, so if we search for in this instructions file, you can see opt_aref and a lot of other code. And you don't necessarily need to understand a lot of it, but if we can come down here, basically we have this one section that is saying if the class that is receiving this method is a hash, then we're just going to go ahead and directly call the hash lookup. Call this RB hash aref. Versus if we look at the exact same instruction set for the set call, which was opt_send without block, it's much smaller, and it's got VM method search. So it actually has to look up the method. It has to go through ancestors and say, oh, do you have this method? Do you have this method? And so Ruby optimizes hash calls by skipping that method lookup for whenever we're using a hash versus using a set. So by the way, do not subclass hash. Do not do it. This explicitly checks the caller to see if you're a hash. So if you have subclass hash, or you say, I don't subclass hash, I don't even know what that means. Well, if you're using hash with indifferent access, you're using hashy, rack utils header hash, then you are using a subclass hash, and that comparison will fail, and then when it does, it has to fall back on a regular method lookup, which is slower. Also, by the way, inside of rack, this hash utils header hash is extremely expensive. If we could just remove it from rack, we would save 23% request time. So every single request in your Rails app would be 23% faster, which would be really cool if we could do it, but we can't. So if you start building things not subclassing hash, you don't have to worry about being put in a scenario later where you can't remove it. So please don't subclass hash. Thank you, Siri.
Just doing my job.
Yeah, exactly. All right. Okay. So we switched from a set to a hash. Here we are building. We're taking that set and we're building a hash. Now it's going to skip the method lookup. Did it help? In my example case, we were running about 18 seconds to compile this app, and we brought it down to 17.9 seconds. Yeah, 1.8% faster. Burn, baby, burn. That's the Ruby speed I'm looking for. Are you with me? Okay. Not good enough? Okay. Well,
So I've been called every name.
My first thought was, look at that homeless guy with those nice rollerblades. Where did he get those?
Used to laugh at him, but then I would see him riding around and really think, man, that guy really is barely even pushing himself down the boardwalk, yet he seems to be gliding. So he's definitely tapped into something.
He's really good, you know. I mean, for his age, it's great.
Okay, so our last performance improvement didn't quite pan out. When that happens, we need to keep gliding. We need to keep going on to round 2. When we do this, we can take a look, and previously you can see that the first entry has changed. It's no longer set include. But now let's take a look and focus on the second one. Again, we're going to use this -- method call onto the stackprof command. And when we do this, we are going to see that, oh, okay, it looks like this is the method body of digest. I know it's past the screen, you can't see it all, so I wanted to fit it all, and it looks a little something like this. Okay, so to paraphrase, we're saying if it's a string, or it's a symbol, or it's a fixed num, or a big num, or a true class, or a false class, or a nil class, or an array, or a hash, or a set, or an encoding, then do something for each of those cases. So just as a mental exercise, if we pass in a set object into this, then we have to make 10 separate comparisons before we ever even determine that this is a set object. To make it even worse, we have the same iteration where if we pass in an array or a hash or a set, it calls back into itself. So if you have a set of sets, it has to make 10 comparisons, and then the first element's a set, and it makes 10 comparisons for those and 10 comparisons for those. So one thing that a lot of developers aren't totally in tune to is that if and else if is hidden iteration. So if we can remove this, then we can go faster by getting rid of that iteration. One of the ways we can do this is with a case statement, or we can also do it with hash lookups. So previously we had code that looked a little bit like this. After some optimizations, it looks kind of like this. Which one do you prefer? Okay, this one. So, but it's not entirely clear what's going on. We have a new constant. We are passing the class into this constant. And so what's happening is we're actually storing our logic inside of our hash. So here we're calling into the hash with the class, and that's going to give us constant lookup time. Previously, we had to iterate and say if, else, if, else, if, else. And then all of our logic is going to live inside of lambdas. When we actually look at that hash, it looks a little bit something like this. So we can go down to the array case. So we're passing in the class of the object that we want to digest, and then it's returning back a lambda. Into the lambda, we pass the value we're digesting, as well as the digest object. It's going to add and tell our digest it's an array, and then it's going to iterate over each and every single one of those. And you'll notice inside of the lambda of the hash, it's actually calling back to the same hash. So what we've done is we've built a recursive data structure with lambdas and hashes. Yeah. So when we put this into our code and we executed it, was it any faster? So not all of the time scales I'm going to be presenting to you are totally linear. So last time we ended off with 17 seconds. This section started off with 14.9 seconds, and whenever we optimized it, we got down to 12.53 seconds, which is about 16% asset compilation speed up with no cache. So this is like the worst case you're ever going to see. You're just running rake assets precompile on production for the very first time ever, or you just blew away your cache forever. So we're going to be repeating that for all supported types. You saw array earlier. We're going to do nil. We're going to do true. We're going to do false. We're going to do numeric and all of those things. So really quick question: who here likes audience participation? All right. Okay. So I got I don't know, it was like 10 people. Thank you very much. That was it. That was the audience participation. So thank you. Thank you very much. Now, can we go even faster than this case? Here, we're still just using Ruby code, and we have all of these different cases where we have our hash, and then we are passing in a constant into it. And the thing to note is that all of these are actually constants. The string class, hash class, true, false, nil, array, set, integer, are constants. And so there's a method on hash that I bet you didn't even know about called compare by identity. So typically, if you create a string and a string of foo, and you put that into your hash, and you look it up with another string of foo, it will return back that element. If you have an identity hash, it compares the object and not the value. So because all of these, every single time we pass in a string class, it will be the exact same object. It will be it is the string constant. It is not a new instantiation of the string. We can use this. So the code for doing this is insanely simple. All we had to do is call .compare by identity, and then we rehash it to let Ruby know, okay, we've changed things inside of our hash. It was also necessary to get this to play nice with JRuby. And so when we did that, we got an additional 7% speed improvement with one line of code, which is, I don't know about you, but it's like, I'll take it. So, okay, I went through a lot of that pretty quickly, and you might be thinking, wow, okay, this guy did something crazy with lambdas and hashes, and sprockets is faster, that's cool, how can I apply it to me in my daily life? Well, let's work backwards and take a look at what exactly I did and what we did. So first we started off by identifying a goal. When we're talking about Dr. John Kitchen, he said his goal is just to do the basic things in Skate. For us, we said we want to make sprockets faster. After we did that, we gathered potentially useful tools. Dr. John Kitchen, slow-mo, he got some headphones, an iPad, looks like some sunscreen, some wrist guards, some rollerblades. Personally, I would have gotten a helmet, but it's not like I'm a neurologist. For us, we got profiling tools. We use StackProf in this example. Another one that I really like is Derailed Benchmarks. I'm a little biased because I wrote it, or just Derailed. And then we have to iterate on our problem. So Slow-Mo said not only did he want to skate, and skate a lot, but he wanted to do less work, which is coincidentally what we need to do in order to speed up a program. Whenever we want to make our program faster, we have to have it do less work. We have to think about how can I optimize the program to remove work from the program. And to better understand how to do that, you need to better understand how your programs actually work and how they execute and how you can optimize it. For that, I recommend Ruby Under a Microscope if you're using Ruby. It's really informative. It'll walk you through how Ruby does a lot of things. And it's also where I got this lovely performance debugging tip, which is inside of Ruby, you can actually, it will tell you how it will run its own code. So you pass in a string of code, and it will show you the instruction sequence used to disassemble your code. That's how I got to that opt aref and that opt send without block. And it's okay if you don't understand everything that's going through it. A, Ruby Under a Microscope will help you understand, and B, you can kind of just grep around the source code and get some more information, and that'll give you a starting point. Please, whenever it comes to performance work, please cheat liberally, and please stand on the shoulders of giants. There's a great repo called Fast Ruby by Juanito Fadas, and he based it off of a talk from Eric Michael Obers, and it's open to anyone who says, oh, it turns out that in my code I had an array and I was calling .reverse .each over it. And it turns out it's actually much faster to just call reverse each. And it's filled with a bunch of really small micro tips like that. So even if you don't understand why it's faster, you can just go on here and learn, oh, when I see this, do this instead. When I see this, do this instead. Or if you can wait, if you find slow code, if you use your StackProf or you use whatever profiling tools to isolate code that is really slow, then you can come on here and say, oh, does it match anything on here? And it's pretty interesting. It's pretty interesting trivia just to go on there and be like, wow, I didn't know that was faster. And the more you understand about how your code works, the faster you can make it. I also recommend finding a speed buddy or buddies, several people hopefully that you work with, maybe in a local user group that you can when you find some slow code, maybe you can bring it to them and brainstorm. Oh, what techniques can we try? What tools? And it, this stuff is kind of addicting because when it's like, oh, it's code speed golf. How fast can I make it go without having to just how fast can we make it go? So in the abstract, like Aaron, I also fudged a little bit. I wrote that we would see how fast your program will go, leading probably some people to believe that there was C code in this presentation as well as Go code. So I don't want to leave you hanging, totally. There is some C code. If you can use the gem SAS C Rails as opposed to just the gem SAS Rails, this is going to be using the C extension, which uses libsass. So SASE uses libsass. When you do this, then we're going to be looking at there we go. Need that flame animation. 31% faster. And so Sprockets 4 should support SASE out of the box. It doesn't yet. And also, I want to note that you don't necessarily have to abandon your language for speed. If you find a part of your program that is really, really speed dependent, then you can tag team it with other languages, such as C and C extensions, or you can use Rust with Helix, as well as you can use Go with Gorb. This is a little experimental. Also, JRuby. So. Another thing that we want to speed up when we were talking about assets is compile times. If you want to just speed up pure boot time of your applications, I recommend Bootscale. Bootscale is going to cache your require lookups, which without it, your gem takes longer every single time the require takes longer every single new gem that you install onto the system. For me, on my app, codetriage.com, which is probably the first time you've ever heard that app name ever before, it brought us from 6-second cache compile time to 2 seconds cache compile time, which is about 300% faster. And I'm not really going to complain about that.
Frankly, at this point, I'm just trying to get to the end of my life without becoming an asshole again.
Dude, I like the look. I like it. How's it going? Hello, Purple. You're wearing purple.
The people that love slow-mo are cheering for one person that got away, that escaped and got to real freedom where he skates all day, doesn't apologize. He's simply doing what he wants to.
This is your good old days. It only gets worse from here on, okay? The good old days are these.
So in programming, the number one thing to remember is don't be an asshole. Don't apologize for programming languages you love. Set your own goals and go at your own speed. These are truly the good days of your programming life. I want you to please live them to the fullest. So right now, I want to take a second if you can all just kind of look up whatever you're doing. If your mind is somewhere else, I want you to stop and breathe. Think about what you want to do with your career and your life. And slow down a little bit. I want you to evaluate whether you're going in the right direction, if you're doing what you need to do. So, everybody, one last time with me. And now,
we are ready to skate.
Thanks. I don't think I have time for questions.
Any questions? Or are we still in slow motion?
Are you still holding your breath? I never told you to continue to breathe. Please continue to breathe. Please continue to breathe. Over there?
Sure, we'll take a question.
Thanks for nice presentation schemes. Where do you see libraries like concurrent Ruby? Like your presentation was about like improving Ruby's performance, but from the application point of view, because you work at Heroku, how libraries like concurrent Ruby are helping?
So I really like concurrent Ruby. I have a branch of Sprockets that actually uses concurrent. Well, so actually, Sprockets 4 now depends on concurrent Ruby. We are concurrently writing out all of your files. Previously, it used to do all of the asset compilation, and then later on, it would write out all of the files one by one. And now, in MRI, if you're using threads and you're doing I/O, so for example, if you're writing to a file, it can actually do that in 2 threads at the same time. So we're taking advantage of that. And then there's a lot more parallel things that I want to do with Sprockets, but I need to make Sprockets work first, which is a pretty tough job. But yeah, I mean, I see a lot of use cases for concurrent Ruby and like thread pools. If you're interested in that, there's a really good book by Jesse Stormier. I think it's just called Threads or like Working with Threads or something. I read through that. I mean, I will say that it does require some knowledge, and especially like the debugging story is not quite there. Like if you're coming from some other systems, there might be some like more concepts that Ruby doesn't have. It's like interops or some other things. But generally, I really enjoy working with it as a library maintainer. And I also am looking forward to it's like guilds or whatever other type of abstraction comes out for parallel computation. Good question.
Question. So there are 2 schools of thought in testing. So one school that says performance as a test, and there are others who don't add performance testing as a part of test. Do you have any opinion on this?
Do I have any opinions on performances testing? So my biggest issue running any types of performance tests is getting consistent results. Like even on my own machine, if while I'm running a 5-minute long benchmark, if I get bored and I open up a browser tab and then load like Google Calendar or something extremely JavaScript heavy, it's like I have to. Whenever I run benchmarks, I run the command and I add and say like I'm done. So my computer's like, hey, I'm done. I close everything and I like literally have to walk away from my computer. So I'm a little nervous of any kind of thing that would actually fail me. Like even in cases where I've made a code change and using something like benchmark IPS, I can say it is statistically significantly faster than this other method. If I run benchmark IPS 100 times, I can still get that one fluke where it's like actually not faster. So like in my and maybe that's a tooling question. Maybe that's a automatically rerunning those tests X number of times. I think it would help in some cases to have some sort of performance monitoring. I think Ruby Bench is a really interesting project where they have said, all right, every single new, you can hook up these like micro benchmarks, and then every single new version of Ruby that comes out and every single new version of Rails that comes out, they run the benchmarks, and so you can see the graph change. I would prefer something a little bit more like that, where it's not as super strict as like a pass or fail version of a test. But I also think performance is one of those things that you shouldn't care about it until you need to care about it. like if you spend the very first library you ever make, you know, like brand new gem, if you stress, you're like, oh my gosh, I saw this thing about this recursive hash thing and these lambdas, and I'm not doing that. Am I doing everything wrong? It's like, don't stress. Just make it correct. And generally, my process is make it correct, and then make it fast. And yes, once it is fast, it would be nice if there's some sort of regression testing. And I would like to see more ecosystem support and even just more options for doing that. Like, I think it would be a great idea, but I haven't personally been able to do that on any projects yet. So,
cool. Thanks for the answer.
Yeah. Do you have any projects that have that as a?
No, but I on some of the critical projects we have had performance benchmarks where the build would actually fail if, you know, some of the tests were actually like would be too slow. And so that has helped out, like especially the case you mentioned where you work on something, you make it faster, and then you don't want to, again, that particular code to go slower. And so, like, we've successfully added some filters for that.
Cool.
All right, give it up for Schneems.